Okay, I think we should be live now. Let's check YouTube.
I can see an encouraging little thing that says live.
Okay, we're just concluding. We're live, yes.
Hooray!
Welcome, everyone. Welcome to the next session of the J Champions Conference. I'm honored to introduce you to Holly Cummins. Holly is a senior principal software engineer at the Red Hat Quarkus team. And before that, she had several roles at IBM and led projects for enormous banks, tiny startups, and everything in between. I just copied from your resume. But at JSpring in June last year, I saw her talk, "These 5 tricks can make your Java greener, cheaper, and nicer." And it was a real eye-opener for me. And it also inspired me to talk about the amounts of unnecessary data that we as developers are sending between various systems, microservices, and things like that. So thank you, Holly, for the inspiration to use my electronic experiments to spread another message. Today, Holly will talk about the future of development, or our jobs getting harder or easier. And I'm sure it will be an inspiration again for me and definitely for everyone who's watching. Holly, the floor is yours. We should have your screen now. Okay,
Cool.
go.
Thank you very much. We were just talking earlier today about sustainability in software development, and as Frank mentioned, one sense of it is in terms of the environment and the climate in particular, but another sense of sustainability is for us as software engineers, and what impact does our job have on us, and can we keep going, and can our industry keep going, and can our profession keep going? So that's really sort of what I want to talk about today. So as Frank mentioned, I work for Red Hat. My day job is that I'm helping to build Quarkus. And a while ago, I was doing something to the class loaders. And apparently it was something terrible that I did to the class loaders, because I got this exception. And if you look, the exception said invalid magic. And at that point, I just thought, how am I supposed to do my job? What do I do with this? How where do you go when the computer tells you that the magic is invalid? And it turns out that this exception isn't actually as silly as it seems. And every Java file starts with a little sequence, aux cafe babe, and that's known as the magic numbers at the beginning. And so I had somehow managed to create a class file that didn't have that, and so everything got upset. But it did take me quite a while to go from this error message that said my magic was invalid to the actual problem. And I think this is something that is at least somewhat new for computer science and for software engineering. If you look way back, computers, they were a lot less magical, and the way we interacted with them was a lot less magical. And the first computers really were all managed using punch cards. And so the punch card was used for data, and it was also used for programming. When I read up on it, I was reassured to read that people actually wrote out the program in a human readable form first, and then they translated it to the punch card. So the punch card was sort of a compilation process, but a lot more manual. And this technology is actually very old. It predates computers by about 100 years. And the first punch cards were used to automate fabric looms, and they were invented by Jacquard. So we had this really ancient technology without magic, and now we're sort of in much more of a magical era. And of course, we evolved from there. So we started with the punch cards, and then we ended up with things like COBOL. And, if you look at what Margaret Hamilton was doing, her code looked like this, which I know because it's now available on GitHub because of the magic of open source, which is really cool. So this is part of the source code for the Colossus 2A and the command module for the guidance computer for Apollo 11. And this, I love being a developer. I love programming. And I have to say, this does not look like much fun. to write. It looks pretty much like hard work and pretty hardcore. And what's interesting about this is now to us, we look at this and we're like, whoa, that is serious engineering. I'm not sure I'm not sure I want to do engineering that's serious. But at the time, Margaret Hamilton was actually the person who invented the term software engineering. And when she invented it, her colleagues sort of said, "Oh, that's cute. No, 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 that's not engineering. You know, what we're doing to build the rockets is engineering." But of course, our perception has changed, and now it's really clear that what we do is engineering. We don't always do it entirely well, but it is engineering. And then, of course, things moved on from there. So in 1974, we got what was considered the first personal computer. And so this is the Altair 8800, and it was the first computer that someone who wasn't, in the industry or doing something in industry could just buy. But the state of computers at the time was that the computer itself, it was relatively affordable. So this computer sold for about $400 at the time, which is around $2,500 now. So if you think compared to something like, an iMac, it's actually about the same price. So achievable for most people. But unlike an iMac, this doesn't have a keyboard and it doesn't have a monitor. And those were the really expensive components. If you wanted to add a keyboard and a monitor to your Altair 8800, that ended up being about $25,000, which is why the interface to this computer was through the switches and the lights. And you would enter your program by flipping the switches, and then you would read the output in binary off the little lights. Again, this looks hard. And I did a similar style of programming for a university module. And we did it for one session. And then, much to everybody's relief, they then gave us a keyboard and a display because it is really hard work. It's so hard to get the input in, and it's so hard to get the output out. But things have got a lot better. So now, and for the last 20 years or so, we've had Java. And it's pretty expressive, it's pretty fun to use, it's a nice place to be. But of course, nothing ever stays the same. So our industry now is moving on from things like Java to things like large language models. And in order to get the best out of the large language models, then we need disciplines like prompt engineering. So the power of these things is pretty incredible. So I gave a one-sentence description of a program that I wanted to ChatGPT, and it gives me a whole bunch of code back. And then there's more code. And then because that's not enough, then it gives me a really nice explanation of the code that it wrote. And then it goes on to add more stuff of like, well, you didn't ask for this, but here's some other stuff that you might like. And so then there's a whole bunch of that. So it looks pretty compelling. We'll come back to how useful this actually is. But what it means now is that our stack is really different from how it was 20 years ago, and certainly very different from how it was for someone like Margaret Hamilton. So at the top of our stack, we have the application, as we always have done. At the bottom of the stack, we have the transistor network, as we have done since transistors replaced vacuum tubes. In the middle, we have things like machine codes. On top of the machine codes, we have assembler. On top of the assembler, we have a high-level language. On top of the high-level language, we have libraries. And then on top of the libraries, we have a framework. And then now, in order to help us deal with the framework, we have something like an AI coding assistant. So it's a lot of layers. And the higher up that stack you go, the more abstraction you get. So we're now living in this very abstracted world. That's pretty good. I'd rather be dealing at a high level than a low level, I think. So what can possibly go wrong with this type of programming? And the answer, as always, is, the first answer to what can go wrong is other people. I was really surprised a while ago because Quarkus does a whole bunch of nice little tricks for boilerplate elimination and giving you a nice programming model. And I just posted a little video on Twitter of a before and after. And just to, sort of expand the video, what I was showing was Quarkus logging. So with Quarkus, you now have an option to do logging in a different way, because logging is one of those things that's always driven me absolutely mad, how inefficient the logging process is in Java, because you have to initiate a logger and you have to tell the logger the name of the class that you're in, which always strikes me as so error prone. This is the kind of thing that gets cut and paste errors, because I cut and paste it from another class, I forget to update the name, and now all of a sudden all of my logging is corrupted. And it's just stupid as well. Why do I have to tell this program what program it's in? It should know. It's the computer. I'm just a person. And so what Quarkus does is you have a Quarkus logging class, and you can just import that class and start logging to it without having to initialize it. I think this is really cool. The internet disagreed. So one of the first comments I got was horrible. And I was really surprised. It wasn't just, well, I maybe would choose not to use this. It was, this is horrible. And then, the sort of, I got more comments. So if one is not able to write a simple code and depends on generated code, then he is not a developer. So here we have this, really strong assumption that you see everywhere, and I think we don't even necessarily think about it, that if you are higher in the stack, if you are using higher levels of abstraction, then that means that as a developer, you are stupider. And we have this assumption that the lower down in the stack you go, the more skilled you are. And this is the exact same assumption that led Margaret Hamilton's colleagues to say, oh, no, you're not doing engineering. You're just writing code. That's the fluffy stuff. We're doing the hardcore engineering because, we're down at the hardware level. And I think fundamentally, this is just gatekeeping, plain and simple. I'll add a note about this gate, by the way. So this is the Arch of Hadrian in Athens, and it is my favorite gate because there's a little gate on top of the gate. So this is when you think your gate isn't gating enough and you need to upgate your gate. So you add a gate on top of your gate. We should all be aspiring to that level of gate, but maybe not in order to keep it. I think this gatekeeping isn't helpful. And I think often it actually holds us back as an industry, because people used to say the exact same thing about garbage collection. So if you sort of read the old internet on discussions about garbage collection, you find things like, avoid using any language that uses garbage collection memory management. It teaches bad habits and makes for lazy, sloppy engineers. Or when programmers rely on a GC implementation to clean up their mess, they become lazy. Or garbage collection encourages lazy programming habits, which I've seen in quite a few Java developers. So, there's this idea that because our language has a Java developer, that makes us lazy. And this is actually fundamentally wrong. I think what it means is that we are using our time for more valuable things. And I said this debate about garbage collection was, in the past, and all of those quotes were from, 18 years ago or so. But actually, this debate about garbage collection is still going on. If you look at a language like Rust as a language, it's very efficient at runtime. It's actually rather less efficient to produce Rust code. So efficient for the computer, less efficient for the human being. And one thing about Rust that a lot of people sort of pick up on is that Rust doesn't have conventional garbage collection. Rust does still do reference counting, which is a form of garbage collection, but people who don't like garbage collection tend to say that reference counting doesn't count as garbage collection, and so it's okay for them to use it. But leaving that question aside about whether reference counting counts as proper garbage collection, reference counting certainly does need the developer to do a bit more work to assign ownership of the objects. And that is one of the things that people really like about Rust. But someone did an experiment and they added a garbage collector to Rust. And what they found was, I mean, it made it less rusty and, well, rustish. And I imagine that, people who were really big advocates of Rust, when they saw this, they were like, no, what have you done to my beautiful Rust? But what they found in this experiment was they added the garbage collection and then they had people complete a programming assignment. The people who were using garbage collection were more likely to complete the task, so they had a higher success rate in the time available. And in fact, they were so much faster that they only needed about a third as much time as the people who weren't using the garbage collector. So like instead of taking 12 hours to write the program, it took them 4 hours to write the program. That is a huge, huge productivity gain. So wouldn't we rather be spending our time doing useful things than fighting to home roll garbage collection? I mean, I think so. But then there's usually another argument that says, well, yes, developer time might be more efficient with higher abstraction, but the program itself is slower. So the lower down the stack you go, the higher your performance. And in general, I think it probably is fair to say that this is true. There's a trade-off between developer time and computer time. And so sometimes in order to write the most efficient code, it has to not necessarily be the most beautiful code. And even if we're working in a higher level language like Java, maybe we have to, have slightly icky code to squeeze the most performance out of this. And I have an example of this that I noticed recently, because in Quarkus, as you would expect, we do a lot of performance tuning and we spend a lot of time looking at our profiles again, trying to squeeze every last bit of performance out. And we had a sort of an interesting puzzle where we were looking at this benchmark and we were finding that when we scaled to like 32 cores, 64 cores, the performance just wasn't what we expected. And yet none of our code was showing in the profiler as the problem. And so Franz, our performance expert, dug and dug and dug and dug and dug and dug. And eventually he figured out what the problem was. And then he realized that it was actually an existing bug that had been reported against the JVM. But I don't think anybody had really realized how big the impact was, because we're sort of talking tens of percentage points of impact on these big systems from this bug. And the bug was to do with instance of caches, that when you do an instance of check, it gets cached, but the cache wasn't scaling properly. And so on a large core, if you had instance of checks, it trashed your machine. So we had to go through our code base, and on the hot paths, we had to replace code that was, fairly readable with these instance of checks with these, trying to solve the same problem in a different way. And the code was uglier and it was longer. But on multi-core systems, it was so much faster that it was worth the trade-off. But this example made me laugh because I was looking at the pull request for this. And the developer who put in this pull request basically apologized for the code. They were saying, I know this code is really ugly Sorry, normally I wouldn't, but for the performance reasons, we have to. But I want to put a caution in here, which is I think this is an exceptional case. This was because we did a lot of profiling and there was a bug. In general, don't micro-optimize at home. Don't try and put in patterns that you think will make it faster. Because the people who spend the most time out of any of us looking at performance are the JVM developers themselves. And the JIT makes stuff really fast. And the JIT is optimized for normal code. When they run their performance exercises, their benchmarks, that's what they're feeding into it. And so in general, normal, not weird, not micro-optimized code is what is going to run fastest on the JVM. That's actually a really good result because that means we can do the easiest thing, and it is also the best thing, both in terms of maintainability, but also in terms of performance in most cases. So there's another argument against abstraction, which is that, as we go higher up the stack, we lose control. And I think, this is a more general issue. It's why people like low-level stuff, because they have the control. And you can see this with the response to my Quarkus logging, that people were complaining that they couldn't control which logger was being run. So to me, which logger is being used is the most boring topic. I really don't care. I don't want to micromanage my logging. Some people did feel the need to do that, rightly or wrongly. But there's another topic where everybody wants to micromanage it, and that is formatting. Formatting is both one of the most boring topics in all of the development that we do, and the thing that will most likely cause an argument and get people sort of purple in the face because they're so excited about this topic. And I used to do a lot of pair programming. And so I was sat next to my pair, and every time we would have a new line, he would have to indent it, and he would be there going space, 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 space. And then we'd have a new line, it'd be a space, 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 space. And then he'd adjust the indentation, space, space, space. I got a little bit frustrated because if he would just save the file, the IDE would align all the braces. So he didn't need to do it manually. But he just really insisted on space, 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 space. So I was getting more and more frustrated. But I thought, at the time we were consultants, our clients were paying us some large amount of dollars an hour. And that time was being spent for my colleague going space, 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 space. And it was not a good use of the time. So eventually I got very frustrated by this. But this is something that I think, all of us, we get really invested in the formatting of our code, and we want it to be exactly how we want, and we want the braces to be lined up this way. And I think this is one of the things that the Go have got absolutely right. With Go, formatting style is not a choice. Formatting style is not something that you argue about. The formatting style is baked into the language, and it's baked in so much that actually you can type Go format and it will format your code. And you don't get a choice about what the format is. So overall, I didn't get on super well with Go, but I loved this. And a while ago, we were talking about this and we were saying, wouldn't it be nice if we would have something like this in Java? So, maybe we could have like a Quarkus format. And then someone said, oh yeah, it would be really nice to have something like that, but it should be configurable. And to me, this is totally missing the point of what Go format does. The good thing about Go format isn't that it formats your code, because there's IDE plugins that will do that. There's compiler plugins that will do that. The build can do that. The point of Go format is that you don't get to choose how it formats your code, so you don't have to waste your time arguing about formatting. And I feel like there's some psychological term for this that that we wanna control the small thing that doesn't really matter, like formatting, because it helps us feel in control in a world that's, maybe a bit big and overwhelming overall. And, definitely it is true that the lower down the stack you go, the more control you have. Sort of. Even this one's not 100% true. Because one of the reasons that we want that control is partly because we want the control, but it's also because we believe that the lower down the stack we go, the more correct it's going to be, the more perfectly the computer is going to do what we intended. And definitely you do see some pretty weird and pretty non-ideal behaviors at the top of the stack. And particularly at the moment, when you go to that generative AI part of the stack, you definitely see some bits where, yeah, that's definitely sacrificed speed for correctness. So if, for example, you ask what the world record is for crossing the English Channel entirely on foot is, it doesn't say it's not been done. What it says is the world record for crossing the English Channel entirely on foot is held by Christoph Andrach of Germany, who completed the crossing in 14 hours and 51 minutes on August 14th, 2020. And this is sort of quite a risky incorrectness. It's just the same as the incorrectness we see with a lot of computer things, which is that it looks so believable. And, for this kind of thing where we know what the wrong answer is and we know what the right answer is, it's kind of funny and it's kind of obvious. But for computer programs, it's sometimes a bit less obvious what's right and what's wrong. And so they've done research where they had ChatGPT answering computer questions, and it had less than a 50% success rate. That is a terrible success rate. But one of the interesting things about this research is that although it wasn't actually very good, its answers were really convincing. And people scored the ChatGPT answers more highly than human-generated answers, even though the human-generated answers were correct. So, and I saw this myself just with that ChatGPT and Quarkus example that I gave earlier. It gave me lots of instructions, and so it suggested things like Quinoa is a part of Quarkus, and it's an extension for Quarkus that gives you a really nice workflow if you're also having a JavaScript front end. And it suggested to do Quinoa build, Quinoa start. This is so wrong. There is no Quinoa. There is a Quarkus CLI. There is no Quinoa CLI, and it wouldn't make any sense to have a Quinoa CLI. The whole point is that it's integrated into Quarkus. And then it added some other helpful suggestions, like make sure to configure your data source in your application properties file. And for production, you would have to do that. But for development, you don't do that. And so this is just like missing a huge usability feature of Quarkus. And so you really have to know what you're doing with these tools. So for example, with ChatGPT, there was another piece of research, and they found it generated mostly insecure code, but it wouldn't tell you that unless you asked. So I think, definitely as we go down the stack, we probably do get more into this pure expression of intent. But we sort of then assume that the risk of errors is lower as we go down the stack. That's not always true. I heard a really interesting story where they used ChatGPT to document a legacy code base. So they had this huge legacy code base. They just pointed ChatGPT at it and said, generate the documentation. And the documentation came back, and some bits of it were wrong, or some bits of it seemed to be wrong. So the developers looked at it and said, silly ChatGPT, look, it got this wrong. And then they looked at it a little bit more, and they realized that actually ChatGPT had got it right, and the code didn't do what they thought it did. So actually, that working at that low level had introduced errors. there's another aspect to that higher abstraction, which is, although it's supposed to save us time, sometimes it doesn't save as much time as we hope. And we're seeing this certainly at the moment with some of the generative AI stuff. So those ChatGPT screenshots I showed earlier, I had to try 4 times to get something that was even remotely sensible. And so I had, it actually ended up being a reasonable amount of effort. And people see this with Copilot as well, that sometimes in order to get the right code out of Copilot, they have to put so much work into their comments and, explain the data range and explain the input shape and explain the reason for parameters. And, eventually the code will be correct. But actually, writing the specification in human readable form was more work than it just would have been to write the code. And all of this reminded me, this idea of like that, if you write code in natural language, that's going to be faster and more expressive. Well, code is actually pretty good as a way of expressing code ideas. And it reminded me of at the start of my career, there was a lot of excitement around model-driven development. And every now and then this idea comes back. But what we found is, you probably don't remember this idea of model-driven development. And the reason is because it didn't actually work all that well. The idea was that, you would make a diagram of your code and then the computer would generate the actual code. But typing is fast, and like dragging and dropping to make pictures, that's slow, especially then when every time you want to customize the behavior, you have to either drill into code or like add more pictures and add like decorations and add, sideways blobs. It was not as efficient as it looked when you just watched the video of it. So I think this question about the speed of development is actually kind of complicated. In general, it's faster higher up the stack, but not always. And there's a sort of a similar mixed story, I think, with cognitive load. When you talk to people like COBOL developers, one of the things that they really love about COBOL is how they can hold it all in their head. Whereas what we see now is that as you go up the stack, because each level of the stack is bigger, there's more to hold in your head. And so when you get to like looking just at the libraries, there's so much cognitive load. And then the framework hopefully reduces the cognitive load, and then hopefully, that the AI coding assistant reduces the cognitive load further. But there still is a lot. We have so many choices now that we didn't have 40 years ago. So if, for example, you look at in 1963, if you wanted to choose a programming language, you had the choice between Fortran, Algol, COBOL, or Lisp. That was your choice. Now, in 2023, you have the choice between Python or C or C++ or Java or C# or JavaScript or Visual Basic or PHP, although hopefully you won't choose that, or SQL or assembly, although hopefully you won't choose that either, or, Scratch, or just, all of these other languages. This is just, the TIOB top 20, and there's loads more beyond these. So, it just goes on and on and on and on and on. And that's a lot. And then let's say you settle on JavaScript. Then you're not going to code just pure JavaScript. You're going to want some libraries. And if you look in the NPM registry, there's 1.3 million libraries in there. Actually, no, there's not. That was the 2020 numbers. Now, there's 2 million libraries in the NPM registry. But assuming you're, if you're programming in most languages, then, you're going to need a framework. And so you have to then, choose your framework. And then, of course, you're going to have to be cloud native as well, because, this is the 2020s. And so then you start bringing in some things to help you with your cloud nativeness. And so in order to figure out what those things are, you go to the CNCF cloud native landscape. And wow, there's a lot in there. And, it just ends up being this puzzle, so to try and piece together which bits of our ecosystem you need to have. But it's not just that there's lots and lots of technology. There's lots and lots of things that we need to do as well. So this idea of shift left, it's partly about when things are done, these important things, but it's also about who does them. And I'm a little bit skeptical of things like shift left for observability, because a lot of the things that you are doing for observability seem to be kind of hard and boring, and I don't really want to do them, although maybe that's just because I'm lazy. And I think, clearly you do need to have these things earlier in the cycle. But what shift left does mean is that the demands on us as software developers are a lot higher. So now, instead of having a separate QA cycle, we have responsibility for our quality, which I think we probably all agree is a good thing, but it's, it's not the same as just writing any old garbage and throwing it over the wall so that QA could send it back. And we have responsibility for security, and we have responsibility for observability. And then because we're doing DevOps, we have responsibility for operations. And then, of course, hopefully we have responsibility for usability, because that's really important. And then hopefully we're doing things like FinOps. And so we take some responsibility for the financial impact of our architecture decisions, which means really we have responsibility for the cloud bills. And that's a whole bunch. And these opses, they're all really positive, but they all seem to be adding to our workload. So in 2023, or now it's 2024, the things that we need to do well is you need to do your apps. Obviously, that's our core job. You need to do ops, and then if you do those two, then you're doing DevOps. But then you can't forget security. So then you've got to do DevSecOps, and then DevBizOps, because obviously the business is what it all comes down to. And then let's combine that all. So you get DevSecBizOps, and then I mentioned FinOps, and it's a lot. So I've heard this idea that instead of shift left, we should be looking more at shift down. And I really, really like it. The idea with shift down is that you let the platforms do the work. So instead of having all of that stuff up at the top that the developer has to take care of, let's move things like operational assistance. Let's move things like observability down into the platform so that instead of having to hand code it, it just works. Let's move that connection between the architectural decisions and the cost. Let's move that into the platform so we don't have to do the heavy data collection ourselves. And so then that means that what we're left with is hopefully just the responsibility for quality and usability. And if we do that, that means that we maybe have enough headspace left that we can start thinking about things like value. Is what I'm doing worthwhile? Another thing that I think has really changed our role is open source. Open source reduces developer tedium. If it's a common task, there is a library for it. And I don't know if you remember when the iPhone first came out, there was this, there was these ads, and, there's an app for that. But now we definitely do have it that, almost any problem you want to solve, there's a library for that, which is cool. But open source does not help with cognitive load, because the problem with there's a library for that is there's a library for almost anything. And with something like Stack Overflow, we end up basically taking quite a lot of our code from the internet. So Stack Overflow did some instrumentation, and they found that over a 2-week period, a quarter of visitors copy something, and there was 40 million copies in that period. And so now, we have, even before we had the generative AI, we were in this model, I think, where the way we reduced cognitive load was we just let other people do the work. And so we copied from Stack Overflow, or we copied just directly from GitHub. I saw this quite astonishing question where someone said a student copied my repo on GitHub and submitted it as their assignment. And then they emailed me to ask me to temporarily make my repo private. So the teaching assistant couldn't see the code, which I think is a new level of cheekiness, to not only steal someone's work, but then to ask them to remove their work from the internet so that you can take full credit for their work. Which I think goes back to the sort of, the original thing of what makes our jobs hard? People. But this copying and pasting, this is something that we've always been doing. But this is exactly how large language models are trained, is copying open source code so that we can paste it into our thing. So I think there's some sort of bigger questions about all of this. And I think the first one really is, will AI take our jobs? That's something that we just, all want to know. It's massively disrupting industries. I was just talking to someone before this, and she was saying that composers are now, that industry is being massively disrupted. So in things like ads, now they don't have a human composer writing the music for the ad. They have an AI composer. For us, I think AI is not going to take our jobs. And if you look at the number of professional developers in the world and how it has changed, in 1940, when we were using vacuum tube networks, there was a tiny, tiny number of professional developers in the world. And then when we went up to assembler, the number went a little bit higher. And then we went to transistor networks and things got better. And then we went to high-level languages. And then it got to libraries, and the libraries made everything easier. And the number of programmers didn't go down. The number of programmers went up. And then we got to frameworks, and the number of programmers went up further still. And so now we're at about 27 million or so professional developers in the world. And so I think with the AI coding assistants, they will change our jobs, but I don't necessarily see it completely reversing that upwards curve. And the reason is because software is not going away. Quite the opposite, actually. There used to be a profession known as a knocker up. And the reason that knockers up existed was when the Industrial Revolution happened and people started working in factories instead of fields. Those factories operated on a schedule, and so it was really important that you turned up at work at the right time. But you didn't have a clock. You definitely didn't have an alarm clock. So how do you get up in the morning? You employ a knocker up. And so a knocker up is actually basically just a human alarm clock, and they go round, and you can see they've got like a big stick and they bang on the window. And this profession lasted a really long time, about 140 years. So even into the 60s, in parts of the UK, there were still knockers up. But that industry since has been disrupted twice. First by plug-in or portable alarm clocks. And of course, now nobody even has any of those because we all just use our phones. But the thing with the knocker up as an industry, the reason it got so badly disrupted was partly technology, but it was also that there is a finite demand for knockers up. The only people who need waking up are employees. You don't need to wake up like the retired people or the children, partly because the children will wake themselves up and it will be at 5 in the morning. But also, nobody needs waking up more than once. Like, once you're awake for the day, it's not like you decide to go back to sleep and then have a knocker up come back an hour later. You wake up once per day. But software is really different from this, because the thing about software is the more software we have, the more software we want. So, you start with the software to do stuff, and then you add the software to do more stuff. And then you have the software to bypass advertisements in the software, so you end up with the ad blockers. And then you end up in an arms race. So then you end up with software to bypass the bypass software so that the ads still show. And of course, we all care about observability. So you have software to monitor the software. And we all introduce bugs. So you end up with software to debug the software. And then you have software to manage the software. And then you have now, we're in this sort of, world of generative AI. So instead of us writing the software, we have software to write the software, which is why we need the software to debug the software. Well, we've always needed software to debug the software. That need is not going away. And then you have software to manage the software that writes the software, because then you need to introduce the guardrails and, the sort of the RAG flows. And then you need software to try and avoid Skynet. And then you need software to tell the people about the software. And then you need software to work out the meaning of life, which is 42. So you could skip that step. But then, we need motivation. So you need software to gamify the software. And it all just, keeps going. This is a never-ending cycle. But of course, that doesn't mean that our jobs aren't going to change. Generative AI allows us to produce code much more quickly. So the productivity expectations for us will be higher. I also suspect that, we get whole new categories of bugs caused by generated code. So we will probably, more of our job will shift from the typing the code to the taking the generated code and figuring out what's wrong with it. And there's another problem with the generated code as well. Copilot had some interesting statistics, and they found that users accepted about 30% of its suggestions. But when they looked at the code base, 40% of the code base was produced by Copilot. So what that means is that the stuff that people are generating is a lot more concise than when Copilot generates something and someone accepts it. It's a lot of code. And that says to me that the information density of what is being generated by Copilot maybe isn't so good. And I think that that style of programming can lead to a lot of things like comments on your getters and setters. You don't need comments on your getters and setters. And comments are good, but too many comments are maintenance liability because they go out of sync with the code. So when I had ChatGPT generate my Quarkus code, initially I was so impressed because it made so much code. It's like, wow, it would have taken me ages to type all this out. But 70% of the code it generated wasn't necessary. So if I had written that code, I wouldn't have typed out all that stuff and the program would have been better. And so when we get impressed by these tools, we kind of go, wow, it generated so many lines of code. It must have done a great job. But we learned as an industry long ago that we shouldn't measure people by how many lines of code they produce. And it's exactly the same for machines. Code is not an asset. Code is a liability. And I think, though, the fact that these models can generate so much code should maybe make us look a little bit hard at ourselves and our programming models. Because if code is so boring that a machine can predict it, like these getters and setters, maybe that code shouldn't even be there. And so I think, something like GitHub Copilot often is actually solving the wrong problem. And if it shouldn't be trying to just generate more and more volumes of code. It should be trying to figure out how we make our code bases more expressive and concise. Because I don't think any of us want to be in a world where our code bases are just flooded with all of this software generated boilerplate. That doesn't help anybody. I think as well, because our computers are so amazing and because they do so many good things, and it sometimes, does feel like we're living in the future, I think there's this sort of idea that maybe it's inevitable that things will get easier. And because, we don't have to program in assembly anymore, things are getting easier. Well, yes and no. It is definitely not inevitable that things get easier. And we have a few examples of this from recent memory. So, for example, in 1995, we had Java. In 1999, the world got EJBs. This was not a step towards making anything easier. And of course, that was a while ago. And I remember like the first time I was trying to understand like passivation and I just it I think we can all agree that maybe it was solving a real problem, but it was not the right solution. And it's easy to laugh at EJBs, and that was a long time ago. It was 20 years ago. We wouldn't make any mistakes like that now, would we? Well, now we have YAML, which just goes to show that we can make, YAML is a different mistake to EJB, but it is not making things easier. Everybody knows that. And so I think really when we design these things, we should really try and focus on design things to make it easy. So, minimize the opportunity for people to get things wrong. Minimize the boilerplate. Minimize the duplication of information because that is annoying and a huge opportunity for error. And maximize the expressiveness of our APIs. And as well, when you're designing something, talk to the people who will be using it. I hate the talking to people bit, but it is something that the computers cannot do, that we have to be doing. And then when you look at how your API is being used, if a developer can save time using your API by using generative AI, maybe you designed your API wrong. Maybe, maybe you needed to make it more expressive. And I think as well, what we really have to be doing is challenging assumptions. So we sort of tend to always do things the way we've always done them. But let's start asking these more radical questions like, what if people didn't have to do this? So with Quarkus, for example, what if you didn't need to configure a database? And this is something that Quarkus does, which is really, really nice. And so if Quarkus sees in your pom.xml that you have a database dependency, so we see you're using a database, and we look in your config, and you didn't take ChatGPT's advice and you left it blank. So we see you don't have a database configured. We know you're going to need a database. So we use test containers sort of in a completely transparent way so that we just sort out a database for you. And that is really, really cool. And it saves so much time. And the only problem with this actually, which is quite a subtle one, is sometimes it catches people out because people spend a long time trying to figure out how to configure the database because they don't believe that they don't have to configure the database. And there's no instructions for how to configure the database because they don't need one. So, obviously they will need one in production. So there's instructions for how to configure it there. But it can be quite difficult to document the absence of something. So that is a little bit of a caution with that style of radical simplification. But despite that, I think it's definitely like where we should be going. And so to summarize, abstraction, people sometimes get grumpy about it. It is definitely a good thing. And as well as abstracting in general, we should be pushing more stuff into our platforms, shift down so that we can make shifting left easier. Coding assistants are really, really good at typing. You should question how much typing you actually want the people using your product to be doing. Let's see if we can get rid of the boilerplate instead of having AI generate it for us. But then as well, I think all of this, some of this is a bit new. It's a period of huge change, but it is so awesome being a developer. And I feel really lucky that I get to do it now. And I feel really excited for what it's going to look like in the future. And with that, I think we've got just a little bit of time for questions.
Yes, thank you. Thanks a lot. I should start using Quarkus.
Yeah, you should start using Quarkus.
To-do list to experiment, but yeah, I'm more a docs writer now, so I'm not really developing a lot these days. But I was just struggling in a small pet project that I'm doing with the logger to find the right dependencies and configuring it, and then you show me that I actually don't need to do that. So
Yeah.
again, I learned something. Thanks for that. And also your remark about the garbage collector. Indeed, it's there to take work away from us that is boring, that is repetitive, that can go wrong. So we should be proud that it's part of Java and that it's
Yeah,
there to help us.
yeah. I mean, it means it has two huge benefits. Well, it has three huge benefits. The first is that it means that we can spend our time doing something else, which is more valuable. And the second is that in general, when what they find in the low-level languages, when people end up sort of home rolling their garbage collection, they have to put something in place, and they get it wrong. Almost inevitably, the memory management ends up being this big source of bugs in the program. But then the final thing is that garbage collection, we have this assumption that garbage collection makes the application slower, but garbage collection, because it rearranges objects in the heap, and that your application will spend most of its time actually reading the memory rather than writing the memory. And so because it rearranges objects in the heap, it can make reading the memory faster. Garbage collection can actually make your application go faster than it would without garbage collection. So then if you don't have garbage collection, you're introducing bugs and spending lots of time in order to make your application go slower. Like there is no win there in any way.
Mhm. Okay, I see we have a question here. Are you using Java or Kotlin?
So for me personally, I am using Java. You can quote in Quarkus with Kotlin, which is just too many noises to try and say in one sentence. But I have not done it personally.
Mhm. Okay.
But yeah, Kotlin I think is such a good example of having that slightly radical idea of like, well, what if we didn't have to do this?
Mhm.
It's cool. It makes things better. And then we're seeing the cycle where now Kotlin, the differential between Kotlin and Java is less than it was a while ago because Java is getting better, which is good for me as a Java developer.
I'm looking if we have more questions. Yes. What is the best stack for serverless Java? I guess you're going to say Quarkus.
Yeah, yeah. I mean, I think that one is so easy. It's definitely Quarkus because for serverless, what you really want is that fast startup time. And if Quarkus as a natively compiled binary will start up in tens of milliseconds, and that is because it's using GraalVM. You can use GraalVM either loose on its own or with other frameworks, but Quarkus has a really nice integration with GraalVM that does make GraalVM, because when you start using GraalVM, because of the closed world assumption, you have to do a lot of config. Quarkus has done a lot of that for you, and it's done a lot of sort of adjustments to the libraries to make them work nicely with GraalVM.
Okay, thank you. I started a few of the commands that we've seen. So yeah, when the magic is invalid, it was a nice introduction for your presentation. And then we have Anis, who really has an aunt who still worked with punch cards. I'm happy I've never been in that field.
I read a thing, and it was saying that in IBM, because they had such a culture of punch cards, and they were a really handy size. So even once they stopped using them for computing, they just still had them everywhere in the office, and they fit really nicely in the pockets on people's shirts. So people would use them for taking notes and that kind of thing. And so they ended up being just sort of a very convenient form of paper, even once they weren't being used for programming.
Yeah, cannot say the same about computer disks. And
Yeah.
someone even has very good memories on assembler. And then someone is asking to learn about Python, but I remember from your talk that I saw at JFOL that Python is not really the most energy efficient language if you're
Yeah.
a developer.
I mean, it is very accessible to sort of, I think Python has a really nice on-ramp, though. I mean, for me, the thing that has improved my skills as a developer the most is pair programming. I think it is such a good way of knowledge transfer while also solving problems. So I think it's easier said than done, but if you can find people to pair program with, that's the thing that's going to take your skills up to the next level.
Indeed, learned from others.
And it goes both ways too. Like when I was pair programming, I'd be the sort of the senior developer in the pair, and I'd be like, now I will teach the junior developer. And then they'd like show me things that I had never seen before. And they'd like use the IDE in ways I had never seen. It was like, oh, and they'd show me libraries that I didn't know. So it's definitely like a two-way thing in pair programming.
Or they ask the right questions to make
Yeah.
you out some things. Yeah.
Yeah. And then you go, I have no idea. I've just always done it that way. I never thought about that.
Gary has used 28 languages in his career. Wow.
That is impressive.
And then Michael, he has a problem with frameworks. He finds that they get in the way more than anything else. I'm not, I've done a lot of Spring development. There's a lot of work that is taken out of your hands because it's already configured, the same thing that Quarkus does.
Yeah, I think this.
frameworks.
Yeah, this one is tough. Like, I think this definitely isn't the first time I've heard this, and I think for some things it definitely does. And you start to see now that sometimes you see frameworks advertised as frameworkless, and so it's like this idea, we're going to do this, and it's frameworkless, but it actually still is like a framework, right? It's still a collection of libraries that are designed to work together, and maybe a programming model, but they've taken out something that is associated with frameworks that maybe people don't like. But I think part of it ends up being sort of the muscle memory too, that like you can do things to do something complicated, you probably will need the framework. And so then even if you're doing something easier that maybe would be easier without the framework, you're so used to you doing it with the framework that it's easier with the framework. But also the other way around, that if you're used to doing it in the more low level way, and you know what libraries work together and you have your recipe, then yeah, you can go fast. And then the framework shifts things and it does things in a different way, and you have to adjust to that new way, which can be getting in the way.
Okay. Someone has a new name for a full stack developer, because indeed you've shown you have all these different languages, all these different frameworks, all these different libraries. So being a full stack is actually being an IT department nowadays.
Yeah.
And this is probably a very good question. 5 mandatory books that a senior Java developer should have read.
Ooh. So the Kevlin Henney and Trisha G book, 97 Things Every Java Developer Should Know, that is a good one, and that's quite new as well, which is nice. Oh yeah. I'm going to look at my bookcase and see. So okay, so now I'm going to go off from Java. So none of the rest of these are Java language specific. So this is just my very personal take. So my others are the Accelerate book, which is nothing to do with languages, but it's so much about how you work as a programmer. And I really like, if you're working in a large company and you start talking about Accelerate, then people go, oh, but we can't do it that way here. And so then you bring out your copy of Lean Enterprise and you show them that. I've learned so much from Lean Enterprise. And then the last one, this is an ancient book, but The Pragmatic Programmer, I found so useful. I learned so much from that. So that's, I think that was 4, but that's my list.
Let's add The Mythical Man Month. I don't know if you know that book.
No, I have not. I'm ashamed to say I have not read it. I know it and I talk about it. I haven't actually read it.
I have it, and it's I'm somewhere in between reading it. But what is the most important thing? So if you add one person to a project for 1 month, then 2 persons will need 2 months. That's a bit the main idea of it. Okay, maybe a last one. We're running over time. There's a bias towards Node when we compare it to Java. Why?
I think it depends what for what. So what I find with Node is, for some categories of problem, some things I think, because I program in both, and I really like the sort of the functional style in Node. Java is getting there, but it's not as fluent as in Node. But what I find drives me mad in Node is the absence of type safety. And what I found is TypeScript did not help with that, and TypeScript just made it more expensive to write, but I still had that lack of type safety. And so I find in Node that things just end up as the wrong type. And I think a lot of banks started switching some of their code to Node, and then they found that things ended up as the wrong type, and they were doing financial calculations, and then they very swiftly switched back from Node. So I think for some things, when your types are just sloshing around and you don't know what type it is and it's the wrong type. Node can be really frustrating, and the type safety of Java is delightful. I think virtual threads is not going to have that radical an impact on that fundamental language thing. I think virtual threads for some categories of problem where you want to be programming asynchronously give you a nice programming model for asynchronous programming. They also introduce a new category of performance pitfalls. So if the library that you're working with does what's called pinning the thread, then it means that instead of your virtually threaded program running massively in parallel, it ends up being forced into single threaded in a way that you didn't want, and it ends up going slower. So it's definitely, it is not a magic bullet. It is a extra tool for people who want to do asynchronous programming. I think that comparison to Node is really interesting because, of course, asynchronous programming and async await is something that is really nice in Node, and it means that for some categories of problem, Node will perform much better than Java in a benchmark because it's got that built-in asynchronous. And so for things like IO heavy, Node will perform much better. And I think maybe we will see for those categories of problems, virtual threads will change that performance differential. But overall, I think you choose the language based on what it feels like to program and that kind of thing.
Okay, thank you. I will end with this one. This is one of the most useful talks
Hooray!
I've ever attended. Thanks. Indeed, thanks a lot, Holly. I think we have to finish. We're running over time. Thanks a lot again for your talk. And
Thank
thanks
you.
everyone for joining us, and have fun with all the other sessions. Next week, we also have 2 more days of this J Champions conference. Thanks a lot.
Thanks, Al.